Hello everyone, so welcome to another LeetCode question, and today we will be solving implementing strStr. It's also represented by indexOf function in Java. So what we have with us is that we have a haystack and a needle. Both are string, and we have to return the first occurrence of needle in the haystack. Otherwise we will return -1 if a needle is not part of the haystack. And one condition that we have been given to us is that if the needle is an empty string, will return 0. So let's go through a few examples to understand what the question is asking. So in, let's say, haystack is hello, and these are the indexes of each character in the string. H has 0, 1, E has 1, and so on. Needle that is given to us is LL. So what we'll return in this case is 2, because LL in the haystack is starting from 2 and is there in this haystack, right? So LL is there and starting from 2, so we need to return 2 here, the index of the first character from where the needle is there in the haystack, correct? So now let's go through the second example. The haystack is AAAA, 5 A's, and needle is BBA. BBA is not there in the haystack. Any continuous stream of characters in the haystack does not contain the needle, so we'll return -1. And the last case is when the needle is empty, then in that case we can return 0. This is the condition that is given to us. Let's understand intuition. So let's say the haystack is represented by the capital S here, and the string is code bug is awesome, and the small string or the needle is bug. We need to find bug. So one can think of a thing that here is that if we ever find a first character from the needle in our haystack, so we can just continuously go through our string in the haystack and see if the first character matches with the first character in the needle, and then we'll check if all the characters in needle from that character is there or not. If it is there, then we can simply return the index of the first character in the S that we found. So in this case it will be 0, 1, 2, 3 and 4. So in this case we'll return 4. So that's what is written. We can run through entire S, which is our needle, to see if our needle is there in the haystack if the first character matches. So that's what we discussed, and the value for this example that we will return is 4. Let's go through the solution. So let's say our haystack in this case is code bug, and we are trying to find a string DEB. So like we said, our I will continuously run through all the characters of the haystack. At this character, we realize that the first character of this guy is equal to the first character in the needle. So now what we'll do, we'll run J1 forward, we'll run I1 forward. At this point, the two characters matches, right? So again, we'll move forward we'll move J forward. And in this case also, the character matches, and then J move forward. And now we see that J has exhausted all the characters of the needle, and therefore we can simply return this index, which we will store earlier, in order to return it as the result, right? So I can move forward, or maybe we won't move the I forward, but we'll just add J to I to check the character in the S and not move I forward, and then we can return I if we ever find that J is, after the loop, that J is equal to the length of the needle, right? Something like that. And let's go to this example where we have the string DO, and if we have the only case where the first character matches with the first character in capital S is at 2, then we'll move our J forward. We can add this to I, check that this 2 matches. Again, we can increment J. At this time, the character doesn't match, and J, after the loop gets over, the J is not equal to the length of the needle. So we will again continuously go ahead. At this time, we'll check E with the first character, doesn't matches. We'll check E with the first character, it doesn't matches. We'll check B with the first character, doesn't matches, and we will run out of all the characters of S, and then in that case we can return -1. So this looks like an algorithm that could work. However, can we do some optimization in this? Actually we can. So let's say our string is CO, capital D, E, capital B, U and G. This is our haystack, and our needle is this debug, right? So at index CI is equal to 2, the current index, let's say, from where we wanted to look if our needle is there in the haystack or not. If we add the length of the needle, which is 5, and subtract 1 from it, so basically the start index is 2 and the number of characters that we have to look in the capital S is 5 characters, right? 5 characters we have to look in it. So the last index in that case will be, start index is 2 and the last index that we have to look is 6. So this will include 5 characters between these two indices, 2, 3, 4, 5 and 6, right? So now let's say if my current index is 3, then what would be my last index? My last index would be 7. But if you look at it at 7 in S, that the last index in S is 6, right? The last index is S is 6. So we need not look for this needle in this haystack after or when the current index is 3 or the current index is greater than or equal to 3. So we can safely break out of it. So this is one optimization that we can do. So the condition that we said is if the current index plus the length of the needle minus 1, basically this index, till this index we have to look in the capital string S. If it is greater than the length of S, length of the haystack minus 1, then in that case we can break. And if we further reduce this condition down, we can subtract this minus 1, and we only have to check is if the index plus the length of the needle is greater than the length of haystack, then in that case we can break. So in that condition we will break and return minus 1, right? Now let's discuss the time and space complexity for this problem. So let's say we have our haystack looks like this, A, B, C, D, E, F, G, H, I, and my needle looks like this, A, B, C, D. So what we are doing is we are going through our haystack, each character one by one, and each character, what we are doing is we are looking at all the 4 characters and checking if our needle is there in the haystack or not, right? So we can think about it like this, like for each character in H, we are trying to look at the needle. So the total time complexity will be length of H into the length of the needle. So that's what we've written, length of capital S into length of small s. And since we are not creating any auxiliary space, so the space complexity will be constant. As part of the additional info, there is one algorithm KMP for string matching or this string finding algorithm. This will be discussed actually later in a medium or hard LeetCode question that we have, and we will add it there itself. Okay, now let's go through the code walkthrough for this. So what we have is a big string called as haystack and a small string called as needle. So the first condition and the condition that is given to us is that if the needle is empty, then simply return 0, right? So if the length of the needle is 0, we are returning 0 as the index of the needle in the haystack. Now when the needle is bigger than the haystack, right? So in that case we should not be able to find this needle in the haystack. In that case we will return minus 1. Now coming to the core meat of the algorithm, we have a first index I is equal to 0, which is running through the entire length of the haystack, and this is the condition that we discussed earlier, and this is the condition that we discussed, that is the last index in the haystack, the last possible index in the haystack would be s dot length minus 1. But if we are trying to find or looking at the needle characters in the haystack, if we add the index I and we have to look after this many characters, right? These many characters, and the last possible index that has to be there in the haystack would be this, right? And the last index itself is if it is greater than the index in the haystack, then in that case we can safely break. Otherwise, if we can look at it, then what we'll do, we have a new index j is equal to 0. This is actually running through the entire needle, and we are checking if at any point of time the character at index j in the needle, if it is not equal to the character at index I plus j in the haystack, then we'll break, right? Because from the current, let's say we had like apple and our string is PLO. So what we did, we were here, the index was 2 and this was my j is equal to 0, and we started looking at this character to this was equal to this, fine. We incremented j, fine. But at this point we didn't find it, and in that case we break out of it. So my j remained 2. And finally we check if j is equal to s dot length. No, j is 2 here and s dot length is in this case is 3. So we are not returning I here, and instead we will simply increment our I and try to look for next character in from haystack and try to find if needle is there or not, right? If we never find it, we'll return minus 1. If we do find it, so let's say we were looking for PLE. So in that case j is equal to this, j is equal to 2. At this we find this string, we find this character in the haystack as well, and j is now 3, and then we will return this I is equal to 2 from a function itself as the index of the needle in the haystack. Okay, so this concludes our algorithm. Thank you.